do I get instant velocity? And the particle is moving along a straight line. And look at the slope at any point. Slope is same. So you calculate slope at 1 and 2. So slope at 1 is equal to slope at 2. So with this, what we can conclude here, the speed of particle is same. So definitely what I can say, no, the body is describing uniform velocity motion. The body describes uniform velocity motion. In uniform velocity motion, let me again calculate the slope. I think you know this will be theta. This will be delta S delta theta. Slope tan theta V1 V2 is equal to tan theta, and it is also equal to, okay, this much will write. And how you define average velocity? Delta S by delta T. Again, it is also equal to tan theta. From geometry, what you can write it? Tan theta equal delta S by delta T. So therefore, what is V average? So in uniform velocity motion, so what happened to average velocity? Here average velocity is equal to instantaneous velocity. What are V1, V2? V1, V2 are instantaneous velocities. And what is V average? So in uniform velocity motion, average velocity should be equal to instantaneous velocity. Maybe if particle doesn't change its direction. In this particular case, it is in fact to, what is the conclusion I can make it? V average bar is equal to V instantaneous bar. This is a conclusion. I'll make it a little bit smaller. Yeah. Yeah, fine. Okay, there's a one best conclusion I'm bringing. Okay, let's come for the second diagram. Let me calculate the slope at 0.1 and point. How to calculate slope? The method is very simple. I'll show by different color lines. There's a one slope. Okay, it's very simple. There's a 0.1 and 2. So here you measure angle theta 2. Here you angle made by tangent with horizontal. We know in FT graph, the slope of tangent drawn in FT graph at a given point will give instant velocity. So looking at the diagram, where theta is more, definitely theta 2 is more than theta 1. What are these green color lines? They are tangents. At 0.1 and 2, I drew the tangent. Then I'll measure that angle, theta 1 and theta 2. Theta 2 is greater than theta 1. Then tan theta 2 will be greater than tan theta 1. What do you mean by tan theta 2 slope? So slope of curve at 2 greater than slope of curve at 1. So in ST graph, what the slope indicates? Nothing but the instantaneous speed. Okay, look at now. Is it uniform velocity motion? The answer is no. In uniform velocity motion, the particle will describe equal displacements in equal intervals of time. Here, it's not like that. It's not in uniform velocity motion. Sir, how do you can show like that? If speed varies, it is not uniform velocity motion. So here, I think one graphical interpretation is a must. There's a curve, there's an experimental curve, what we have. No. I'll try my level best. Particles should cover no, equal time intervals. I'll take it. Just give some time. I'll set right things here. Huh? The distance between horizontal lines should remain same. Yeah. Now let me bring the corresponding to that vertical lines, produce horizontal lines. You can beautifully see the interval is same. This interval is same. Delta t, delta t. What about here? This is delta S1. This delta S2. Okay, agreed. Okay, now you have very beautiful information in front of you. What about average speed in the interval of time delta t at 0.1? This is 0.2. Delta S2 greater than delta S1. So what will happen to average speed? Average speed is going to be different. V average at 2, it is greater than V average at 1. Previously, sir, can you show for previously also? Let me arrange the diagram. We'll move a little bit up, no, so that we'll get a space to scribble all this one. Okay, no, you have everything visible for you. Similarly, let me go for the graph for this uniform velocity motion. This name not needed. Okay, there's a graph. I'm plotting the graph. Already I discussed, once again for your convenience, I'm repeating it. Straight line. Okay, the straight line is not here. Now here also you go for the same thing. Equal displacements in equal intervals of time. Vertical line, black color. If you measure this delta S, it will be same. And this delta T will be same. And these are the points 1 and 2. Look at average velocity. Average velocity at 2 is equal to average velocity at 1, which is equal to delta S by delta T, which is nothing but equal to V1, V2 also. Already I just indicated. A very beautiful information is what I'm presenting here. So look at in this graph, I think, look at the graphs here. So in this graph, the instant velocity, the instant speed was equal to average speed, or instant velocity equal to average velocity. What about here? The particle is having different speed with the time. At one, at 0.1, it's having one speed. At 2, it's having a speed. The speed of particle is increasing. Speed is increasing. It is in fact is accelerating better, you can call. Now calculate the average velocity at 2 and 1. Definitely at 2, it is more than 1. At 2, it is more than 1 year. So look at the now, is it uniform velocity motion? No, it's a non-uniform velocity motion. The body describes non-uniform velocity motion. So is it V average S V average not equal to instantaneous speed. Initial velocity, can it be zero? Not possible. Everywhere non-zero. Average velocity, non-zero. Both are non-zero here. Able to compare this, it's a non-uniform velocity motion. If you get a curve in ST graph, non-uniform. If you get a straight line, it'll be uniform velocity motion. Similarly, let's interpret the third graph. So let me choose the points, experimental points. So there's a 1, 2, 3. Okay, let me just magnify it. Oh, yeah. No. Now look at the points 1 and 2. At 1, what is the slope at 1? First, we'll calculate the slopes at various points. Slopes at 1, at 3, and slope at 2. I think, is it visible? I'll further magnify so that I think there's a maximum magnification. Clearly see this slopes. Slope at 1 is positive, slope at 3 is negative. Slope at 2 is 0. So V1, what we can conclude here, V1 is positive and greater than 0. I'll V2 less than 0. What about, sorry, V3 less than 0. What about V2 equal to 0? Slope negative means speed it will start moving towards negative direction. What about average velocity? You look at the initial position, final position. The net displacement is 0, no? So what is the average velocity for this time interval? It'll be 0. And what about instant velocity? It's 0 at one instant. Now what about average velocity for the points for this interval of time? Non-zero. So what is the conclusion we can make it here? Average velocity, can it be 0? Yes, it will be 0 for some interval. Average velocity can be equal to 0. Maybe 0, I'll write it. Average velocity maybe 0 for, not 0 for all intervals, maybe 0 for some means only for this interval. For this interval of time, it is non-zero. So only for some interval. What about instant velocity? It is 0, no? At some instant. Is in fact 0. At 2, the velocity is 0. At 1 and 3, it is non-zero. So therefore, if average velocity is 0, then instant velocity must be 0. Need not know, not a necessary condition. Here both can be 0. And at 1, both are non-zero. For this interval, if you take it, no, instant velocity non-zero, average velocity non-zero. At 2, what happened? Instant 0. And for average velocity means we should go for interval. So during this motion, what we can say that one, average velocity may be 0, may be non-zero, correct statement. Instant velocity at a given instant will be 0, will be non-zero, correct statement. At this instant of time, non-zero. At this instant of time, 0. At this instant of time, non-zero. Average velocity for interval 1, 2, non-zero. For interval 1, 3 will be 0. Maybe 0 for some interval. V in fact at some instant of time, it will be 0. And V in non-zero at some instant of time. It will also be non-zero. We'll take the next condition. You can see this clearly, the position. So is it possible for average velocity to be 0? Not possible. Average velocity will be non-zero for any interval. Now, what about instant velocity? It can be 0 here, no? 1, 2. At 2, the slope can be 0. Oh, no. Average velocity will be non-zero for any interval of time. You can clearly look at this condition. So you look at this interval, you take it, or from here. If you take it for this interval, it can be zero again. For any interval, maybe zero, you have to write it, not must be. Instantaneous velocity is in fact maybe zero. At 2, it is zero. At 1, non-zero. At 1 and 3, it is non-zero. And average velocity or an interval, if you choose this is interval, it'll be zero. If you choose this is interval, non-zero. So for any interval, maybe zero you have to write, not for all interval. I think the same curve. So somewhere here the slope can be 0, 1 non-zero. So is it uniform velocity motion? Non-uniform velocity motion. Non-uniform velocity motion. Similarly, again, V1 non-zero, V2 will be 0, V3 non-zero. V in, like maybe 0. I can put that statement. V in maybe 0. What about average velocity? The same idea. For any interval, maybe 0. Both are same, these two diagrams. No, if average velocity, let's come for this one. Average velocity is 0. What about instant velocity? It can be 0. It can be 0. Not a necessary condition. Here, what happens? Instant velocity is not at all 0. You can see that one. So where the slope is nowhere 0. That one. So V instantaneous non-zero. V average can be 0. So in a motion, if average velocity is 0, instant velocity must be 0, need not. You compare this. Here what happened? Instant velocity has become 0. If average velocity is 0, instant velocity may be 0. It's some instant of time. So what is the condition? If V average 0, V in must be 0, need not. V in may be 0 is a correct statement. Like this, we have to interpret. So here V in instant 0 and the V average also, though it is 0, but V instant non-zero. If you take this sum interval, this interval of time, V average also will become non-zero. So shall we put a conclusion? If average velocity is 0, instant velocity must be 0. Wrong statement. If average velocity is 0, instant velocity may be 0. Correct statement. If instant velocity is 0, average velocity must be 0. Need not. We don't have any such code. If this is 0, this must be 0, nothing like that. It all depends upon the type of motion. So what is the conclusion? We can make it here. If V average 0, V instantaneous may be 0. If V average non-zero, V instantaneous may be 0, may not be 0. So there's no any specific rule that if this is 0, that must be 0. That's what I just wanted to interpret by so many examples here. Let's conclude with the help of some sentence. If velocity is constant, then speed would be constant. But if speed is constant, then velocity may not be constant as direction may change. Is it a correct statement? If velocity is constant, then speed would be constant. Then speed would be constant. But if speed is constant, then velocity may not be constant as direction may change. I think it's correct, no? The statement is correct. If velocity is constant, then speed must be constant. I'll give another example where it will change the direction. Here, it will continuously will move in same direction, particle 1. If velocity is constant, then speed would be constant. Yes, it must be, no, there's a correct statement. But if speed is constant, then velocity may not be constant, direction may change. As if you see this, it is moving with a speed v2. If velocity constant, speed must be constant. If speed is constant, velocity need not be constant because there can be change in direction. I think the justified. I just give an example with the help of these things. So for this statement, there's a diagram. For this statement, there's a diagram. If a particle is moving with constant velocity, then for any time interval, average speed is equal to magnitude of average velocity equal to speed equal to magnitude of velocity. I think that this again will take help of the graph. Then you go for the slope. If particle is moving with a constant velocity, so I think if a particle moves with a constant velocity, this is a position versus time graph. This is a delta t. This is a delta s. So what is V average? Delta s by delta t. This is also equal to V, no? Since it is moving along a straight line, so no change in direction of motion. Then for such a motion, the magnitude of average velocity or average speed, magnitude of velocity or the speed, everything will be same. If a particle moves with a constant velocity, then for any time interval, either again you pick up time interval here or here, anywhere, any time interval, this will be a valid one. A particle is moving in a straight line without changing its direction of motion, then speed equal to magnitude velocity. Average speed or an interval should be equal to magnitude of average. I think the same thing just now. Average speed or an interval should be equal to magnitude of average velocity. Both are same, no? Instant speed and average speed may differ. I think for a particle moving a straight line without changing its direction of motion, then instant speed and average speed, no, it will be same. Compared to that statement, no, a particle is moving along a straight line. I'll push it here. Okay, look at the this statement, the particle moving straight without changing the direction of motion, then instant speed and average speed may differ. Not wrong statement, no? It's a wrong statement. Huh? The velocity of particle is constant, then average velocity for different intervals would be same or different. Will be same. You can take any interval of time. Everything through graph, better to interpret, so that will be easy for us. Now, if I take this, for different intervals would be same. Different intervals is telling. So the intervals of time, I'll change it. Let's see what we'll get it. Look at the intervals of time. I change it correspondingly. This is delta T1, delta T2, delta S1, delta S2. This is the position. This is the time. What you can say about the slope? Okay, I'll just shade that triangle. Please look at the triangles, which I'm going to shade it. What is the slope of these two triangles? Will be seen. Tan theta 1 is equal to delta S1 by T1. Delta S1 not equal to delta S2. Delta T1 not equal to delta, but still the average speed will be same. And this should be equal to what? The average speed, or it is also equal to instantaneous speed. In uniform velocity motion for different intervals, even then the intervals of time you take it, then definitely the corresponding displacements will be different, but the ratio of displacement time taken will be same. I think this will be same or different. So what we should say, same. I'll strike it out. We'll getting no, all these are not theoretical questions. We should analyze with the help of graph. Last one. If average velocity of a moving particle is 0 for a time interval, then initial velocity at some instant within this interval may be 0. I think we have just now discussed everything. It has come in the form of sentence. If average velocity of a particle is 0 spinning, let me extend the graph. Yeah. This can happen. It can be like this. No. You have very best information in front of you. This is one interval of time. Next, we have another interval of time. There's an interval of times we'll choose, delta T1, delta T2. There's a position. There's a time. So for position 1, 2, V average is what? Will be 0. Agree this? For time interval, okay, AB, I'll write it. So symbols. SA equal to SB equal to SC. So the time interval, so this, let me call this a first and this is second one. So V average for the first, it will be SB minus SA by delta T1. V average for the second interval of time, SC minus SB by delta T2. So this will be 0 by delta T1, 0. 0 by delta T2, 0. Average velocity, no doubt 0. What about the instant velocity here? Here it can be 0, no? And here nowhere it is 0. And at some other points non-zero. So in this interval of time, instant velocity is 0. In this interval of time, instant velocity is non-zero. So what is the interpretation? In interval of time, instantaneous velocity may be 0, or is 0, you can write. At one point is 0, at other point non-zero. In an interval of time, delta T instant velocity is non-zero. Next point. in interval of time delta t2, initial velocity is non-zero. Now you interpret yourself. If average velocity of moving particle is zero for a time interval, then instant velocity at some instant within this interval may be zero. Yes, no? It is zero, yet it is non-zero. Must be zero, wrong statement. Maybe zero, correct statement. So there's a correct statement. Agreed? Just now what we discussed earlier, that's the same set of problems. It's a position versus time graph. You calculate what you get, you'll get a slope. Okay, now let me indicate, let me read question. The diagram shows the position versus time graph of two cats running opposite to each other between two fixed points. Then cat A has greater average speed, cat B has greater average speed. Both cats have same distance and both cats are moving with constant speed. Okay, now what is actually the diagram? The diagram will be like this. Both are having same displacement. Correct, no? So this is a cat B. I think I can't draw the cat. Yeah. Appearing like a dog. There's a cat. So it is running. There's a cat B. Okay, there's a cat. There's a cat A. So they will cross each other. Both cats are moving. Now, which is having, so you look at the slope. There's a slope theta A. There's having a slope theta B. So tan theta A. Cat A as, so now you look at the displacement. So what I suggest is like, is asking the speed, that one. Both are having same displacement. What is the time of journey of A is more than time of journey of B? This will be a little bit difficult. Let me analyze here. This will be delta TB, time of journey. There's a time of journey of cat A. No, both are having same displacement, delta S. So what is VA now? VA will be delta S by delta TA. VB will be delta S by delta TB. Delta TB is less than delta TA. So therefore VB should be greater than VA. So the speed of the cat B has greater average speed. The conclusion. Then both cats have same displacement. It's correct, no? Both are having same displacement. Both cats are moving with constant speed. This is also correct statement. Two particles A and B are moving along a straight line. Describe the motion of particles in following cases. How A and B are moving. So both are having same displacement. Green color and red color, I should take. So both are having same displacement. Both will take same, like a different time of journeys are different. You can see from here. This will be the time of journey of B. I'll write it here. delta TA. This will be delta S. So VA delta TB. So delta TBE is less than delta TA. So VB greater than VA. So who is having more speed? The B particle B is having more speed than A. Who will start early? A will start early. And both will reach the destination simultaneously. Like this, we can interpret. Both will cover same displacement. You can see that the speed of A, this is the speed of B. Both will cover same displacement. Okay, no. Again, we have to interpret. So this will be the so the time of journey of both are different. This is delta TB. Both will start simultaneously. Both will start simultaneously in this case. So A will start earlier. A will start earlier than B. Both are having same displacement, but the speed of B is greater than A. Now what happens here? Both will start same, but with having more displacement, B is having displacement. B will overtake A. So we will start, both will start. Okay, this graph, I'll do correction. It should be like, yeah. The destination is same, no? You can see from this data here. No? So no, what about the speeds? What we can write here? Both will take same time. So like the time intervals are different. The slope of B you have to calculate, and with the slope of A. Theta A, this will be theta B. So tan theta B, tan theta B will be greater than tan theta A. So VB greater than VA. So if this is having a speed VA, this is having a speed VB. And B will overtake A. I think just now I discussed the cat one. So here, both are moving opposite to each other. A and B are moving. A and B are moving opposite to each other. They will cross each other. Then both are having same and VA equal to VB. The graphs will predict so much of information hidden in graphs. Okay, I'll take the next one. Okay, let me read this question. A man walking from town A to another town B at the rate of 4 km per hour starts 1 hour before a coach. Coach means like some bus or anything. It can be tramway or any bus or vehicle. Also traveling from A to B. The coach is traveling at a rate of 12 km per hour. And on the way, he is picked up by the coach. On arriving at B, find that his coach journey lasted 2 hours. Find the distance incremented between A and B. I think it's all about the diagram. I feel. This is the A and B, town A. So I'm taking up of diagram to explain. No, there's a the easiest way of working physics numericals. These are the stations. These are the two places, A and B. Is asking the distance between them. So at t equals 0, the man here, he will start walking. So what is the speed of the man? That would be Vm, I'll write it. Then at a rate of 4 km/h, we know that one. Starts 1 hour before a coach. The coach is here only. The coach is here. Coach means the truck only, I'll take it. I'm okay, so somewhere I'll draw it here. There's a coach, and after 1 hour, the coach will start. No, so there's a time. 1 hour, and the person what in that 1 hour, he will cover some distance. He'll be somewhere here. So how much of distance he will move in 1 hour? 4 kilometers. Now the coach will start. No, able to understand? The man will start his journey earlier. He will start walking. Then after 1 hour, now the coach will start walking here. So the coach, I'll rough diagram will be like this here. So the coach, what happened for first 1 hour, the coach will be attached, the man will walk. Now, by the time somewhere the coach, what happened, will pick up the man. I'll place the what is this? Yeah. Okay, the man will be sitting on it. Will I zoom? So this distance we don't know. Let me excel. So the coach is traveling at a rate, and on the way is picked up by the coach. This one. So what is the time? We don't know this. Let me call T2. Finally, the man and the coach will arrive at the other end of the other point B. So what is the time? 2 hours. His coach journey is lasted 2 hours. So from here, what happened? The journey will start now. So this will be 2 hours. So what is the speed of the coach? 12 km per hour. 12 km per hour. I need to move for 2 hours from here. Yeah, look at this one. This 12 km/h. So for 2 hours. So what is this distance should be? 24 kilometers. There's a velocity of coach. And the man will be in the coach. He will not move. The coach will move now. Okay, we have this much of information. I think any student, if he's able to interpret the problem like this, you can work out very comfortably. Okay, let me look at the man. For man, what is the equation we can write? 4 plus x should be equal to 1 plus t2 over. So what is the distance covered by the man? Distance like from A2, from this position to this position. How much of distance the man will walk? So the man, what happened? First 1 hour he'll walk. Then the coach will start after 1 hour. By the time coach catches the man will be still walking, no? So by the time man moves a distance, the coach will, how much of distance will move? 4 plus x. So therefore, total distance moved by the man to catch the coach will be 4 plus x. In what is the time interval? 1 hour. Time of walking 1 hour plus t2 hour. With the speed Vm. There's a one equation, you keep it. Then for the coach, what we can write? 4 plus x should be equal to velocity of coach into only t2. Because what is the time taken by the coach to catch the man? Because altogether it has to move a distance of 4 plus x with what speed? With a speed vc in interval of time t2. So there's the equation 2. So what are the unknown things? vc we know, velocity of coach 12 kilometer per hour. Velocity of man 4 kilometer per hour. Okay, solving this equation 1 and 2, I'll get x and v2. So like a x I'm getting, I think 2 kilometer. T2 will be 0.5 hour. But what was the distance? Our question is to get that the distance AB, no? So what is the distance AB? You can write it as 4 plus x plus 24. So 4 plus 2 plus 24, 30 kilometer. It's a very general problem. If you're moving from your home to the college, then you have walked. Then meanwhile, the bus started and the bus will pick you up. Then sitting in bus, you reach the college. Nothing big, no? Why you should take physics book? The very general things you might have noticed in your life. I'll indicate the colors a little bit easy for you. Okay, this will be our answer. The distance AB is what that is asked. Let's take the next problem. Let me save the data. Yeah, read the question. Okay, read the question. From a town, car starts at regular intervals of 30 seconds and run towards another town with a constant speed of 60 km per hour. At some point of time, all the cars simultaneously have to reduce the speed to 40 km per hour due to bad weather. Simultaneously, all the cars, I think this is some point, all the cars simultaneously have to reduce the speed to 40 km per hour. I think this will be going to help us a lot. Due to bad weather condition, what will be the time interval between arrival of the cars at the second town during the bad weather? Don't search for formula. Just take help of. So there's a station A. We'll take it out, town A. There's a town B. One car will start. Okay, let's assume that the first car will start. I'm unable to draw the car. Yeah. Okay, this first car will start it. For every 30 seconds, a car has to start the journey. I need some set of diagrams. I will decrease this so that we'll get enough space. Okay, no, I think you are able to see things clearly. A and B. Now there's a first car. Okay, we'll give number 1. Then again, what about the second car? It will start after 30 seconds, no? So it will be here. Second car will start. I'm trying to explain the concept so that it'll be easy for you. Huh? 2, 3. This is 2. Car 1, 2, 3 like this. Huh? Now look at this one. So what is the speed of all the cars? All the cars 60 km per hour. At t equal to 0, this will start. After what time? 30 seconds. Next, again, this will, I think I'll indicate like this. Huh? Again, this will start. What be the distance between them? I'm interested in this distance. Will it be same as the distance between cars should be same? So how to calculate the x? So there should be equal to x should be equal to 60 km per hour into 30 seconds. I think this will become 0.5 kilometer. So the distance between the cars now will remain same. Now due to bad weather, the speed of the cars now will reduce to 40 km per hour. Then what point the distance will remain same. The distance is not going to change. So somewhere bad weather has come. I'll bring those 3 cars. I'm just taking only 3, so you have to take plenty to make concept to understand the concept. I'm just only picking up 3 cars. So due to bad weather, all will change their speed simultaneously. So what do you expect the distance between them will remain same, still x only, because all will change their speed simultaneously. The distance between them will remain same. Now, what is the time interval? The first car will enter now. The first car will reach. Next, second car will reach. The first car now is about to just enter the station B. Next, afterwards, okay, I'll do one thing. Why it is not coming? Oh. I'll show it here. The car 1 is here. I'm not responding. Let me save and see. Okay. We can erase, no? Okay, I'll do one thing. I'll have alternative. I'll erase by white color. Okay, now look at this for every. So what is this distance? Again, will remain same, will not change. The same x only. So after what interval of time it will reach here. So there's now the car 2 is at station B. After some time, the car 3 will come here. No, the car 1 was here. After what time the car 2 will be at station B? It has to cover a distance x with what speed? 40 km per hour. So therefore, what is the T2? The T2, what we can write is earlier we wrote T1, no? Earlier 30 seconds what we wrote it. So I'll do one thing. V1 into T1. So now this is V2. The speed has reduced. So what is X2 now? the same x, what we can write it as v2 into t2. So what is x? 0.5 kilometer, 40 kilometer per hour into t2. This t2 is what is asking. So 45 seconds it will come if you calculate. For every, so here after 45 seconds, car 1 is at station B, at town B. After 45 seconds, car 2 will come to the station B. For every 45 seconds, one car will enter the town B. This idea. So some, I think I feel like at least through diagrams we can solve. It's not that only through diagram. Very easier method. Anybody can draw cars. Anybody can draw straight lines. Anybody looking at diagrams. Anybody can write equation. What is this x? So look at the car 1. Earlier it was here. Now it is here. So it has moved a distance x. So what is x is equal to? Speed of the car into the time interval. Finish short. So we'll get the x. So since all cars will change the speed simultaneously, even after raining, the distance between the cars will remain same. So here some more rain occurs. Blue color clouds will show it. Here rain occurs. So because of that, they'll decrease the speed. Let me take the. Okay, these are the some types of numericals what I have picked up. Few more are there. Let me cover in the next class. I think I just took the lot of content what I gave here. In the next coming class, what happened? We'll discuss few more problems. Okay, kids, like today's class, we had a discussion on the applications of uniform velocity and incident velocity, uniform velocity, some graph problem. If they give question, how to solve, we should draw a physical diagram, one physically what happens. Looking at that diagram, then what will happen? We will write some equations. Then known things, unknown things, then the set of formulas. So try to look at the methodology to solve the problem, not like something question I'll read, some formula is there, I'll dump something in the formula, I'll get answer. Not possible. So slowly with a small numericals we have started. So read the question, what actually going on, express that, take help of some straight line. Okay, body moving along straight line, particle, in place of particle you can assume a person, you can assume a vehicle, car, bike. Show that they're moving, that differentiating their different positions. Then look at the question data, try to indicate it, speed, distance, time, what all given, what is unknown thing, how to write some equation, then solve. You may get answer. So make a habit of solving physics questions. Unless you don't solve questions, concept clarity will not come. Just mere reading theory will not help you. You have to put effort in solving numericals. Okay, tomorrow we'll continue from here. Okay, thank you all of you. Take care. Bye, kids. See you.